Hi, Sam Roberts here from Roberts Geospatial. It's April 2022 and in Australia on the East Coast it is raining cats and dogs and has been for 2 months. So I thought we'd look at some global hydrology data and talk about flooding and so forth. So on the screen here you can see a web page of a researcher called Dai Yamazaki. He's from the University of Tokyo, has a research group, and he's published some global hydrology raster data sets. And I've downloaded these and we're going to have a look at them. So I first became aware of this group and the work that they were doing because they produced a product called the MRR DEM. And I've spoken about this before, and there's some articles on my website about this DEM. I recommend it to you. It's a 3 arc-second global DEM, and it covers the whole Earth apart from Antarctica. So you can download it here from their website. And if you're using MapInfo, if you go right down the bottom, you'll see that it's also in MRR format, so you can download a single MRR file. And that's a file that I created and sent to Dai, and he put it onto his webpage. So following on from that work, having created a higher quality global DEM, he then went on to do what he's really interested in, which is hydrography or hydrology. And so he's created this new product called MRR Hydro. So here's the web page, and I'll put these links on the YouTube page. So this is hydrology data that's based on or derived from that MRR DEM, as well as other data sets. So if you go down a bit, you'll see here, these are their products. So it has flow direction, adjusted elevations, upstream drainage area, either flow accumulation area or number of pixels, river channel width, and height above nearest drainage. So I've downloaded the upstream drainage area, which is in kilometers squared, the river channel width dataset, and the height above nearest drainage dataset. And in this case, drainage is a river that has an accumulated flow area of more than half a kilometer squared. So the datasets are down here a little bit. So they're all zipped up into tar files. So you have to download, for each data set, there's 57 tar files, and inside those tars, once you unzip them, there are 1,150 TIFF files. So they're all 3 arc-second resolution, and they're all in Geodetic Coordinate System WGS84. So you download all of those things, and the first thing that I do when I get global data sets like this is convert them into MRR. So you start off with 1,150 TIFF files for each data set. Now that doesn't include the overview, so you have to create an overview file. So that brings you to 2,300 TIFF files for each data set. And then if you want to display those data sets at the same time in some kind of visualization, well, if you've got 3 of them, well, then you're looking at closer to 7,000 rasters open at one time. And that's a difficult proposition for any system. It's hard to do that efficiently, and you have all sorts of other issues. So I tend to convert to MRR. So the thing about converting to MRR is, firstly, you tend to shrink your datasets down because it uses compression and so forth. But one of the design criteria of MRR was not just to compress data, but to allow people to reduce the amount of information in their rasters to only that information which is relevant to them. So why have 7 decimal degrees of accuracy on something when really you can only justify, say, 1 meter accuracy instead of 7 decimal points. So there are mechanisms in MRR to reduce the amount of information, which really is probably just noise, and so reduce the size of your files. So just briefly on the MRR processing. So I use a join process. So the upstream drainage area data. So I clipped out all cells that were less than 1 square kilometre of area, and I reduced the area accuracy to 0.1 square kilometres. So that took me from a 44 gigabyte data set without overviews to an MRR that's 5.5 gigabytes with overviews. The river width data, I clipped out all cells that were less than 0.5 meters, and the river width accuracy was reduced to 1 meter. And all other pixels that have other designations, I removed those. And so I ended up with about a 750 megabyte MRR for river width, including overviews. And then with the height above nearest drainage, this is a larger data set, I reduced the vertical accuracy to 0.1 meters, and so that was a 57.6 gigabyte data set without overviews, and as an MRR is 28.7 gigabytes with overviews. Just one thing about the processing. So when you create overview pyramids for things like the upstream drainage area and the river width, so these data sets, because I've clipped out all the data that's got a smaller area, it's clipped it right back to the river streams themselves, the river beds. So basically you just have lines running through the data set everywhere. And so the overview pyramid has to be constructed, or preferably is constructed, so that those lines don't drop out, because they're only 1 pixel wide. And if you use the normal rules, then they'll drop out very quickly, and very quickly in the overview pyramid you'll get no data at all and you won't see anything. So I used a different rule to create that overview data that preserves information as you go up, so nothing drops out. So you can see data all the way up to the top of the pyramid when you zoom right out, and that allows you to find where your data is. Otherwise you see nothing at all when you open the raster, and then you only start to see data once you zoom in. So you do that with the drainage area and the river width. The height above nearest drainage is just a normal raster. So I just want to show you one thing in MapInfo that I don't think people are too aware of. So in these rasters, let me just pop that over there. So I've got raster info here in MapInfo, and you notice that there's this field called metadata. So in MRR you can have these metadata fields, and there's one at the raster level, then field level, then band level, and so forth. And into this you can put all sorts of information. So I'll just bring that up over here, and you can view it in MapInfo. So here's the metadata. So I've scraped some information off Dai's website. So for each raster there's a description of what it is, information about the licensing for the product, where it came from, the citation for the product, the processing that I've done, or that the group did, and then the processing that I did. And then I've even included in here the XML processing script, which I ran to join all of these rasters together. So all that information is in there. You can copy that script out and use it again and change it and build a second data set. I just wanted to show that. And notice down here you've got an apply and a cross, so you can actually edit these after you've created the MRR and change the information, add any information, doesn't matter. It doesn't matter how big the MRR is. You can add as much information as you want in there, and it'll just save it straight into the MRR. So that was something that was introduced in a later version. Perhaps people don't know it's there, but that gives you some information about the provenance of your raster.